When you're adding fractions or subtracting fractions, you have to have a common denominator. So right now, 2/3 and 1/8, they do not have the same denominator, so we need to make them be the same. So a common denominator I could use would be 24. So that means I have to multiply this 3 by 8 and also the 2 by 8. Whatever I multiply on the bottom, I have to also multiply on the top. So the 8 has to get multiplied by a 3. So the top has to also get multiplied by a 3. So now this fraction becomes 16 over 24. And the second fraction becomes 3 over 24. Now that I have a common denominator, I can just add my numerators. So 16 plus 3 is going to give me 19. And then I keep that common denominator, which is 24. So we're going to keep that in mind when we're adding rational expressions. The first thing you want to do is to factor all of your denominators. So what we're going to do is factor the second denominator, since the first one is not factorable. So we're going to leave this as x minus 1. And then we're going to rewrite x squared minus x as x, and then x minus 1. So we're taking out the GCF of x. We're left with x minus 1. So now we're looking at the two denominators, the x minus 1 and the x times x minus 1. We want to see what they have in common and what either of them are missing. So they both have an x minus 1 in common, but the first one is missing an x. So I need to multiply the top and the bottom by x. So what I'm going to do here is distribute the x on the top. So this becomes x squared plus x over x times x minus 1. And then we have minus 2 over x times x minus 1. So what you don't want to do is you don't want to cancel anything out yet. What you do want to do is make sure that you FOIL the top. So the top should never be left in factored form. You should never have parentheses on the top until the very, very end. So make sure that you multiply that x into the x plus 1. So now that the denominators are the same, I can smush the top together, and I have x squared plus x minus 2 over x times x minus 1. And we can leave that denominator in factored form. We just want the top to make sure that that's in standard form. From here, we can now factor the top. So if you can factor it, you want to factor it. So multiplies to negative 2 and adds to 1. We're going to change that to be x plus 2 and x minus 1. The denominator is the x minus 1. From here, if we can cancel anything out, we want to do that. So I can cancel out the x minus 1s, and we're left with x plus 2 over x. And that's our answer. And we can't cancel out the x's since the top x is attached to the 2 through addition. We still need to find our domain restrictions, and that's just going to be off of the common denominator. So if we set x to 0, we get 0. So x cannot be 0 or 1. Okay, so if we look at another one, again, first step is to factor any denominators that can be factored. So x squared minus 4, we're going to rewrite that as x plus 2 and x minus 2. The x plus 2 on the other one can't be factored, so we leave it. We look at the 2 and we think about what's missing from 1, if there's anything missing. So the second fraction is missing an x minus 2. So we need an x minus 2 on the bottom and an x minus 2 on the top. So what we have now is x over x plus 2x minus 2 plus x minus 2 over x plus 2x minus 2. And what you do not want to do is cancel out the x minus 2 in the top and the bottom. You cannot do that yet. Because we're adding, we need to add the top together. So x plus x minus 2 is going to be 2x minus 2. On the bottom, we have that x plus 2x minus 2. Now from here, you want to factor if you can. So if I factor the top, I take out a 2, I'm left with x minus 1. On the bottom, I have x plus 2, x minus 2. So that didn't help me by factoring it because the x minus 1 can't cancel with anything. So you can leave this as your final answer. You can leave the previous step as your final answer. You want to try to factor it and then see if you can cancel things out. If you factor it and things don't cancel out, that's fine. You just leave your answer. So your restrictions will be x cannot equal -2 or +2. Okay, when you're subtracting, the same thing applies. You're going to do the same steps. However, you want to make sure that you distribute the negative sign. So first thing I'm going to do is rewrite any of my denominators in factored form. So the first one is going to stay exactly the same, but the second denominator, I can factor this. So multiplies to 2 and adds to -3. I'm going to use x minus 2 and x minus 1. So now when I look at these two denominators, the first one is missing an x minus 1. So it needs an x minus 1 on the bottom and an x minus 1 on the top. We have to FOIL the x minus 1 and the x plus 3 together. So that's going to give us x squared plus 3x minus 1x minus 3 over x minus 1, x minus 2 minus, so I'm going to actually put this in parentheses, 6x minus 7 over x minus 2, x minus 1. Now the reason I put it in parentheses is because I'm subtracting, so I want to make sure that I distribute that negative sign to both the 6x and the -7. So I'm going to simplify the top now. So x squared, I'm just going to kind of smush this all together. So x squared plus 3x minus x becomes plus 2x minus 3. And then I'm going to have a -6x, and I'm going to have a positive 7. So that negative sign is going to both of these terms. Okay, over x minus 1, x minus 2. So I'm going to keep simplifying the top. I'm going to push this together and make this x squared. And then I have a minus 4x plus 4 over x minus 1, x minus 2. Once we have the top in standard form, we're going to try to simplify it by factoring. So we're going to factor what multiplies to 4 and adds to -4. We're going to use -2 and -2. And on the bottom, we have x minus 1 and x minus 2. I can cancel out the x minus 2's. So what I'm left with is x minus 2 over x minus 1. And then the domain restrictions are going to be off of what makes the denominator 0. So x cannot equal 1 or 2. Alright, so we're going to look at the next one. I'm just going to do it on a different page. So it was x minus 1 over x plus 5 minus x plus 3 over x squared plus 6x plus 5. So we're going to keep that first fraction the same since we can't factor the bottom. And then we're going to factor what multiplies to 5 and adds to 6, x plus 5 and x plus 1. So we look and we say the first one is missing x plus 1. So this needs an x plus 1. So the top also needs an x plus 1. Okay, we're going to FOIL the x plus 1 and the x minus 1. So that's going to be x squared and then minus 1, because the x and the negative x will cancel out. On the bottom, we have x plus 1, x plus 5. And then we're subtracting. And again, I'm going to use parentheses so that we know that we need to distribute that negative sign. Okay, it doesn't matter the order if I write x plus 1 or x plus 5 first. So now I'm going to smush the top together. So x squared minus 1, I'm going to subtract the x, and I'm going to subtract the 3. So x plus 1, x plus 5. So now on the top, I have x squared minus x minus 4 over x plus 1, x plus 5. So if I try to factor the top now, what multiplies to negative 4 that adds to negative 1, it's not factorable, so this would be my final answer. And the domain restrictions, x cannot equal negative 1 or negative 5.